Good evening. Welcome to my basement. I'm going to start out my lesson on operating scientific notation with addition and subtraction with an addition problem where I've got two great big numbers. I've got $15 million, sure wish that was mine, and I'm going to add to that $5 million. Wouldn't that be nice if we could be adding all that into our checking account? So anyway, if I'm going to add these up, I've got to line them up so that the decimal points are in the same spot. So I'm going to put 5 million underneath 15 million. The 5 is in the millions, so it goes underneath the 5 in that millions. And I would line it, ooh, that's not very good, is it? So I'll line them up, all the zeros, okay, and then 0.00. And if I add those up, this is easy, lots of zeros, comma, and I have 15 million and 5 million is really just 20 million. So I want to look at this. I'm going to change these into scientific notation and add them that way so you can see. And this is not one of the examples on your paper, so if you want to write this on the back, that would be good. So you can pause the tape here and write this down if you'd like. And now we're back, if you've paused it. All right, and we're going to write 15 million in scientific notation. So we know that the first factor in scientific notation has to be between greater than 1 or greater, and less than 10. So we would have to make that 1.5, that's bigger than or equal to 1. And then what would I have to multiply that by, what factor of 10, so that if I move the decimal point from here where it is here, over till it gets there, I would have to go, count these, we would have to go 1, 2, 3, 4, 5, 6, 7 spaces. So that means we're going to multiply by 10 to the 7th power. So that's 15 million written in scientific notation, plus, now we're going to do 5 billion in scientific notation. So that's going to be 5, I could put 5.0 if you want, you don't really have to, times 10 to the 1, 2, 3, 4, 5, 6 to get it the decimal point there where it is, that's a comma, that's a comma. So that's going to be 5 times 10 to the 6th power. So when we add these, when you add in scientific notation, if you look at your little steps there that I have written down for you, okay, it says rewrite the powers so they are the same, okay? And we do that because they have to have the same place value. Just like here, we had to line these up with the same place values. The 5 and that 5 and that 5 are in the millions. There's no 10 millions here. And we've got everything lined up with the decimal point. Well, if we were to just add these the way they are, we would be adding 5 million to 15 million, and I've got to get that 5 underneath this 5 just like this. Some kids look at that and say, well, I'll just add the 5 to that 1, and it'll be 6.5, but you're not in the same base over here, so you can't add them until you've got the same base. So what we could do is, since this one's already 1.5, let's just leave it, and it's in 10 to the 7th, let's change this one so that it's also in 10 to the 7th. So the scientific notation, that's going to change. It's not going to be between 1 and 10, but that's okay because we're going to add them. And then we'll go change it back so that it is a number between 1 and 10. So if I want this to be 10 to the 7th, then I would have to have moved my decimal point one more place to the right to add 7 places. So that means the decimal point would need to be back here behind the 5 so that when I move it 7 places times 10 to the 7th, these would be the same thing because I would be starting my decimal point here and moving it over 1, 2, 3, 4, 5, 6, 7, so I would have 5 million. So now I can add this to 1.5 times 10 to the 7th. So I'll take this over here and I'm going to line them up. So I'm going to say, I can put a 0 in front of there, 0.5 times 10 to the 7th. You don't add the bases. All you're going to do is add, this is called the mantissa. So that's going to be 5 tenths of 5 tenths is 0, which is 10. I'm going to carry the 1, so that's 2.0 times 10 to the 7th. Now, this answer should be the same as this when I write it out in standard form. So if I do that, and I move this over 7 places, that means I'm going to have 7 zeros behind the 2. Well, let's see. 2, then I'm going to add 1, 2, 3, 4, 5, 6, 7. So I'll go 3, 3. Yep, I got 20 million. These are insignificant digits. That's just the place value for the change. All right, so you want to get a common base, and then you can line them up with a decimal point, add them, and that would be your final answer. So let's do the first one. It's very similar to that. It's just we're not ever going to put them in standard form. Boy, this isn't erasing very good. It's my rag. Sorry about that. Well, here we go. All right, so we're going to take 5.97 times 10 to the 24th. And we're going to add that to 7.35 times 10 to the 22nd. So we have to have the same base 10. So this one has the higher exponent. So let's leave it, whichever one has the higher exponent, let's leave that one, and let's put this one as the higher exponent, then we can line them up and add them. So we need to have that to be 10 to the 24th. So right now this number, this decimal point, gets moved 22 places that way. Well, we want it to be multiplied 24 places that way, so we got to bring it back 2 places this way. So if I shove it back 1, 2, then that's going to be 0.0735 times 10 to the 24th. So if I move it 2 this way, then I'm at 7.35, and that's after I do these 2. If I take 2 off, then I've got 22. So that would be the number that I now want to add to hit this. So I'm just going to line them up. So I line up 0.0735. So that's this number, same as that, times 10 to the 24th. So they're both same base 10. Now when I add them up, that'll be 14, whoa, no, wait a minute, 5 and the 3, that zero's there, and then 14, 7, 7, raise 1, so that's 10, carry another 1, so that's 6. And it's in base 10 to the 24th, so we keep it that way. So my final answer is 6.0435 times 10 to the 24th. Okay, now for the subtraction problem. The subtraction problem, this is example 2. This was example 1. Example 2, we've got 1.02 times 10 to the 25th, and we're going to subtract 4.87 times 10 to the 24th. Now when we subtract, this is being subtracted from this. So this, I want to be a bigger mantissa than this one. So this is the one I'm going to switch. So it's at 10 to the 25th, and I want it to be 10 to the 24th. So if I move it 1 place back this way, then, oh shoot, I want to move it the other direction. It's got to be bigger. Oh, yeah, what am I saying? I'm moving it this way. So now I go over 1, there's 1 space, and then the rest of those would be 24 more. So then it would be at 10 to the 24th. So this is going to be, sorry about that, 110.2. I've moved it over 1 space, so now I only have 24 left to go if I move it over 1. So 10 to the 24th. Now I can subtract 4.87, let's put a 0 there so I can line them up, times 10 to the 24th. Oops. And I'm going to move this times a little bit. Okay, so now when I go to subtract, they're both 10 to the 24th. But look, now I can say when I take this away, I'm going to have a positive answer. So I'm going to borrow from the 2, make it a 1. So this becomes 10. 7 from 10 is 3. Now I've only got 1 there, so I'll borrow from the 10 and make that 9. So that's 11. 8 from 11 is 3. 4 from 9 is 5. So it's 5.33, and then times 10 to the 24th would be your final answer. Okay, so if you need to rewind this and do these again, be my guest. And tomorrow, when you come into class, I would like for you to just look at me and give me a wink. And that way I'll know you watched the video. Please don't tell anybody else. Just between you and me. Wink. Have a good evening.